So in this problem, we're given that a ball of mass m is moving to the right with initial velocity v0. We're going to call this the positive x hat direction. And it collides with a larger ball of mass 4m initially at rest. The two of them collide elastically, and we're asked what their final velocities are going to be. So we know that momentum is conserved because this is an isolated system, and we know that since they collide elastically, energy is also going to be conserved. So this tells us that mv0 is equal to mv final, the final velocity of the smaller ball, plus 4m big V, the final velocity of the larger ball. We also know that 1 over 2 mv0 squared is equal to 1 over 2 mv final squared plus 1 over 2 times 4m big V squared. So now what we're going to do is we're going to use this equation to find an expression for V final in terms of V0 and big V. We're going to plug that into here, and we're going to solve for big V, and we're going to use that to then find both of our final answers. So manipulating this around, we get m times V final is equal to m times V0 minus 4m times big V. I'm now going to take out the directions and just use the magnitudes, and this is going to give us the speed V final is equal to the speed V0 minus 4 times the speed big V. Now I'm going to square this over here so I can plug it in more easily. V final squared is equal to V0 squared minus 8 V0 big V plus 16 big V squared. Now I'm going to multiply this by 2 over m. We get V0 squared is equal to V final squared plus 4 big V squared. I can plug this in up here. We get V0 squared is equal to V0 squared minus 8 V0 big V plus 16 big V squared plus 4 big V squared. We can rearrange this, cancel out the V0s, and we're going to get 20 big V squared is equal to 8 V0 big V, which gives us ultimately big V is equal to 2/5 V0. Now we can plug this in back into this equation. We get V final is equal to V0 minus 8/5 V0 is equal to negative 3/5 V0. So this gives us our final speeds. All this means is that the velocity V final is moving to the left at speed 3/5 V0, and the velocity big V is pointing in the right-hand direction. So now we're going to plug these back into our momentum conservation and energy conservation equations to make sure that they make sense. So first of all, into the momentum conservation equations, mv0 is going to have to be equal to mv final, which is minus 3 over 5 v0 times m, plus 4m big V, which is going to be 8 over 5 times m times v0. So 8 over 5 minus 3 over 5 is just 1, and so we get that mv0 is equal to mv0, which is exactly what we want. Now in order to conserve energy, we know that this equation has to be the case, and so I'm going to ignore the 1 over 2 terms because they all have them, and it's going to be easier to do the math without it. So mv0 squared is going to have to be equal to mv final squared, which is just m times 9 over 25 v0 squared, plus 4m big V squared, which is 4 times 4 over 25 v0 squared times m, which is 16 over 25. And so we get 16 over 25 v0 squared plus 9 over 25 v0 squared is just 25 over 25, which is 1 v0 squared. We get mv0 squared equals mv0 squared, and energy is indeed conserved. So now we've checked our answers. We know that these are our final velocities.